Hi all, this is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss about the topic, the terminologies used in big data environment. So let's get started into the topic. So the terminologies used in big data environment are classified into six: in-memory analytics, in database processing, massively parallel processing, symmetric multiple processor parallel systems, parallel and distributed system, shared nothing architecture. So the first terminology is in-memory analytics. We all know data can be accessed from non-volatile storage such as hard disk or secondary storage devices, which is a very slow and a cumbersome process too. To combat this challenge, we have to pre-process and store data in the form of queues or aggregate tables, query sets, etc., so that the CPU can able to fetch a very small subset of records. But doing this requires thinking in advance. If we have to analyze later, again we have to pre-process and store data. So to eradicate this problem can be addressed using in-memory analytics. In in-memory analytics, all the relevant data will be stored in RAM. So the advantages of using in-memory analytics are for faster access, rapid deployment, better insights, and minimal IT environment. So this is the difference between our traditional computing and in-memory computing. In traditional computing, the main memory will have the database of all records, whereas in-memory computing, only the subsequent records, whatever is needed for analysis alone, will be fetched by CPU and it will be processed. So, what is the next terminology? It is in database processing. In database processing is also called as in database analytics. Here, it works by fusing data warehouses with analytical systems. Typically, the data from various enterprise OLTP systems after cleaning up, that is, after deduplication, scrubbing, removing noise, and unwanted missing values, all through the process of ETL, will be stored in enterprise data warehouse, or we can call it as the data marts. So here in DIM database processing, the database program itself can run the computations, thereby eliminating the need for export, which in turn will save time. The next terminology is symmetric multiprocessor system. So in SMP, here you will have a single common main memory that is shared by two or more identical processes. The processes will have full access to all input output devices and are all controlled by a single operating system for instance. So here the SMPs are tightly coupled multiprocessor systems. Each multiprocessor system will have its own high-speed memory, which is termed as cache memory, and are all connected through a system arbitrary, that is the system bus. The next one is MPP, which is massively parallel processors. Here in MPP architecture, it consists of nodes with each having its own processor, memory, and the input-output subsystem. Also, it has an independent OS runs at each node. So MPP refers to the coordinated processing of programs by a number of processes working parallel, but these processes have also have their own operating system and dedicated memory too. They work on different parts of the same program. So the MPP processes communicating using some sort of messaging interfaces. That is using messaging interfaces. They will communicate around the network. The next terminology is about the parallel and distributed system. So parallel system is a tightly coupled system, whereas a distributed system is a loosely coupled system. The parallel system will have the processor which will cooperate for query processing. The user will be unaware of the parallelism. Whereas in distributed database systems, they are loosely coupled and are also composed by individual machines. Each of the machine run their individual application and serve their own respective uses. So this is about the distributed and parallel computing. The next terminology is shared nothing architecture. So in nothing architecture, neither memory nor disk is shared among multiple processes. The shared nothing architecture is the most three common type of architecture for multiprocessor high transaction rate system is shared memory, shared disk, shared nothing. So shared memory, a common single memory is shared by multiple processes. Shared disk, multiple processors share a common collection of disk while having their own private memory. Shared nothing, neither memory nor disk is shared among multiple processes. So the shared nothing architecture view, shared RAM, how it will be, shared disk, shared nothing. So the main advantage of using shared nothing architectures are fault isolation and scalability. So fault isolation, it will provide a benefit of isolating fault, that is a single fault in a single node will be contained and confined. Scalability, the disk is a shared resource. Different nodes will have to take turns to access the critical data. So a distributed shared disk system thus compromises on scalability. So these are the different terminologies used under big data environment. Thank you.